Thanks everybody for joining us today for our virtual fireside chat, turning concepts into kilowatts, the path to solar success. I thought we have a bit of fun here today with this concept. Sitting in front of the fireplace, it seems to be a good time to do it, being the upcoming holiday season and whatnot, very festive. And so we're excited to have our guest here today. We have Micah from Paragon Engineering Services. He specializes in the engineering and delivery of solar PV projects, supporting organizations from their earliest stages of feasibility and electrical design through utility coordination, construction support, and final commissioning. At Paragon, he has helped commercial, municipal, institutional, and industrial clients navigate everything from roof assessments and system sizing to interconnection requirements and performance optimization. Micah is known for taking a practical, engineering-first approach, ensuring systems are safe, code compliant, and built to perform reliability for the long term. We're excited to have him here today and share his experience and shed light on what it really takes to bring a solar PV project from concept to completion. Thanks, Micah, for joining us today.
Good morning. Thank you.
Next up, we have Scott Barker from Grand River Energy Solutions, who leads the development of solar PV, microgrid, and distributed energy projects that help organizations lower costs and accelerate decarbonization. With a background spanning in engineering, business development, and large-scale project delivery, Scott brings a practical, technology-agnostic approach to planning and implementing solar solutions that are reliable, financially sound, and tailored to each client's needs. His experience guiding projects from feasibility to construction and long-term assessment management, this makes him a trusted voice on what it takes to develop successful solar PV systems in today's evolving landscape. Thank you, Scott, for joining us today.
Good morning.
Okay, I'm just going to let in a few more people here before we get rolling here. All right. So, why are we here today? Well, before we get into today's conversation, it's worth acknowledging why so many businesses are exploring solar PV right now. Energy costs continue to be one of the largest operational expenses for commercial facilities, and many organizations are feeling pressure to reduce long-term exposure to rising electricity prices. At the same time, customers, investors, and corporate boards are placing a much stronger emphasis on sustainability, carbon reduction, and demonstrating real progress towards ESG commitments. Solar PV has emerged as a practical, proven solution that helps businesses achieve both goals, lowering operating costs while reducing emissions and increasing energy resilience. For many businesses, solar is no longer a nice to have. It's becoming a strategic investment that supports competitiveness, brand leadership, and long-term planning. So with that, let's gather around the fire. All righty. So, gentlemen, as a owner, how do I understand my building's true potential for solar, and what should I be looking at during those first few conversations? Scott, maybe you can start us off here.
Sure. But what I would first caution is maybe not jumping right to solar and is stepping back and asking, what am I trying to achieve? Because depending on the nature of your business, and maybe you've got the kind of profile where you're consuming a lot of energy at times when prices on the grid are high and you're a big consumer, maybe something like a battery would actually be a better fit for you. So we really encourage people to step back and ask yourself, what am I trying to achieve from the perspective of financial objectives, operational objectives, and sustainability objectives, and then on that basis, you can then look into what is the right technology or combination of technologies to achieve what you're looking for. And in terms of undertaking this process, you can certainly go directly to contractors, but I'd certainly caution you that if you go to a car dealer, they're not likely to tell you what you really need is a bus pass or a rideshare app. So I'd probably recommend starting with your key account reps at the utility, and then maybe look at engaging with an independent or owner's engineer who can support you through the entire process.
So I brought up the tree that you had put together there, Scott, for everyone to see here.
Yeah, and this is probably worth bringing up again later, but it just helps with some of the questions that are worth asking yourself. So, what am I trying to achieve? And then there are some questions about what's the nature of my organization, and do I want to be putting money into this myself? Do I need to find a partner that can put in capital for me? And those are good questions to be asking yourself. Is once you sorted out exactly what you'd like to use technology wise and whether it's feasible, which Mike, I'm sure we'll talk more about how we actually do that. Then you need to think about who's actually going to pay for this, and what do I want those agreements to look like.
Okay, great. So, Micah, what's your thoughts on this? The initial first conversations that we're having.
Absolutely. Thanks for asking. Uh, I think there are good questions that you want to ask first, and then some other questions that you want to ask a little bit later once you have some of those answers. I think that there's a value in talking to solar contractors. You could talk to someone like Scott. You could talk to an engineer or an owner's engineer. And then as your project starts to take form, you'll have a better understanding of, who are the best people to support you in this. But maybe before we go further, I just want to maybe talk about the value of getting the first bits right, the feasibility and figuring out these questions. One of my favorite expressions is that no one has the time to do it right, but everyone has the time to do it twice. And this is very true for solar. There are a number of different things that if you get right at the beginning, the whole project goes wonderfully, smoothly, cheap, right? Easy. And those same things, if you get them wrong at the beginning, they can be a real pain point. And Scott and I will maybe have a few minutes at the end to talk about some of those lessons learned and times when we've seen people make those mistakes and hopefully not mistakes that you'll repeat. In terms of evaluating the feasibility of a project, this question of, is this a good project? Should I go forward with it? There are a couple of project killers that are always good to identify right out of the gate. And the first is to talk to our friendly utility, reach out to Innova, whether or not you're doing that directly or through your solar contractor or someone like myself. There is a process called a PCIR, which is it's essentially a pre-connection request. Is there capacity for me to connect this project to your grid? Because if the local grid just doesn't have any capacity there, then the project is really done before it gets started. And then the second question is, if you're looking at a rooftop project, does my roof have capacity to put solar panels up there without having to do really expensive reinforcements that may make the project no longer feasible? Worth noting on the structural capacity piece that January 2025, we had some new building code elements come into effect that made it a little bit more robust, the requirements to put solar on the roof. Where previously we were looking back at the last 50-year worst storm. Now we're starting to look at the next 50-year worst storm because we all know that weather is getting worse and not better. Next thing I wanted to chat about, once you've identified that those project killers are not going to ruin your project, then we want to start looking at the question of whether or not this is actually a good project. So you start looking at system layout. Do I have enough roof space on my roof, or do I have rooftop units and gas lines and stacks and vents and fans everywhere, and there's not actually much room to put solar panels up there? What about the roof age? You don't want to put a solar array up there and then have to replace the roof 2 years later. And in fact, I know some larger organizations with many buildings will even identify when they're replacing the roof and make a plan to put solar panels on each of those roofs as soon as they're done so they can maximize the use of that lifespan. You want to look at shading. Do you have a high rise going up right beside your building that's going to shade all of your solar panels? There's a building in Kitchener actually that put solar panels up about 10 years ago, and all the solar panels are looking directly at the building next door, so they never see direct sunlight. It's unfortunate. Existing electrical infrastructure, the voltage, the ampacity. Are you going to have to replace your switchgear before you can connect this large solar facility into your building. And then you get into questions of system size versus connection cost. So at 100 kilowatts, there's relatively minimal protection requirements from Innova. But as we start to get up through 500 kilowatts, 1 megawatt, or even larger, the expense of the protection system starts to ramp up, and that becomes a factor in terms of choosing the right size that you want to build your project for, so you can optimize those costs. What was the next thing I was going to chat about? Oh, export versus non-export. And this is going to answer a question I think popped up about net metering. So net metering as a basic concept is when there is excess electricity being generated by your solar facility that is not being used by the building, that excess electricity can go backwards through the meter and show up as a credit on your utility bill, and you get credit for that later on, and it's great. The alternative to that is called load displacement, where you're essentially just offsetting the load that you're using internally. And if there are circumstances where you're generating more than you're using, then you wouldn't get a credit for that. And there's a couple of times when that's better. But starting with net metering, it doesn't qualify for the Save on Energy funding. And I think Scott's going to dig into that a little bit deeper later on. That's typically better when your load profile doesn't follow the sun, or it doesn't follow, summertime heat waves. It's for when you've got lots of roof space, you can fit lots of kilowatts on the roof, you've got large electrical gear. So essentially, we're not going to be constrained in terms of how many solar panels we can get into this system. And it works well with kind of, your warehouses, your large flat buildings, that type of thing. Now, when we look at load displacement or non-export, the big advantage for this is that it does qualify for the Save on Energy grant, which is a significant incentive. Sorry, do you mind just giving us one more? Thank you. Yes, it's better when the load profile does follow the sun, i.e., if your electricity demand is going to be peaking when the sun is shining the most, then your solar panel and your load profile are going to be aligned. So best example I know of that is chicken barns. In the summertime when it's hot, you got all these fans that are running really hard. And if you have a non-export system, then your solar is going to be generating at the same time as you're using that electricity. This would also be good if you've got a larger building that's maybe higher without a lot of roof space, or there's high demand or intensiveness. I'm going through, some of the details here, but just to give you sort of the basics, if you want to know more about which of these is going to be better for yours, definitely encourage you to speak with somebody that knows about it. Either myself, Scott, or anyone in Innova can probably advise you. And then maybe just the last thing to chat about here.
Yeah, and maybe before you jump to that, Mike, I'll just note
please,
that
Scott.
this is something that's going to be iterative for you as well. So you're going to be able to at first say, okay, well, based on what I'm trying to achieve, if what I'm really trying to do is displace the maximum amount of energy, I want to supply the most possible clean energy to my building, or have the maximum carbon reduction impact, then net metering is usually going to be the better way for the majority of customers, I would say. So you factor that in. You may also have a situation where I don't think it's as much an issue in Innova territory, but we've seen it elsewhere, where the utility comes back and tells you simply you are only allowed to do a non-export solution, and so that's what remains to you. So I would just encourage people to, well, and sort of caution you that you may think you're coming to a conclusion, but then there are other factors that are going to inform this, and you may cycle through this a couple of times, as well as, in spite of one type being eligible for one incentive or another, you kind of want to look at the big picture and say, what is the overall dollar amount? Not just, hey, I may be getting a small system for 50% off, but if that only takes 10% of my load, is that really a big deal? So it's unfortunately it's not altogether straightforward, and that's why it's helpful to work with resources that have been through this.
Thanks for that, Scott. And you're absolutely right. It is valuable to be clear that there is no one clear winner for either one of these. It really is case specific. And maybe the last point I'll make with regards to feasibility is to speak to who you might want to be asking these questions of. In many cases, for smaller projects, speaking with a contractor or an EPC, someone like Scott, who is going to design and build the system for you, is the right fit. Um, there's no sense adding additional costs if they aren't warranted. But if you're considering a larger project, or if risk mitigation is really important to you for any reason, then it can be valuable to engage an owner's engineer. And if you're not familiar with that term, essentially what that is you're engaging a technical specialist that is going to sit on your side of the table, scrutinize everything that is going on, and make absolutely sure that you are getting full value for what you're paying for. So essentially, you've got an expert that's sitting on your side. If it's a smaller project, if you trust your vendor, there's no reason that you would need to engage that additional cost. But when it's warranted, it can be really valuable.
Excellent. Great guys. That was definitely a mouthful. I hope everyone's been taking notes and whatnot. Good thing we're recording this so you can refer to it later. But as you can imagine, there's a lot of work, right, to get the ball rolling here versus just going to your neighborhood solar store and starting to pick up some panels there. So I guess the next question we want to ask here is. After we know what's possible or what our goals are and where we're headed with the system is how do we get started? And maybe we'll go to the mic on this one again.
Well, jumping ahead a little bit, but the first thing I always recommend is getting a connection impact assessment going. And essentially, that is a technical document that asks Innova, can I please connect this solar facility to your grid at this location, this size, these circumstances, those inverters? And they will do an evaluation and come back and say, yes, you can. Here are the circumstances under which you connect. So valuable to have that out of the way right at the beginning, because the last thing you want is to, buy an expensive system, have it installed, and then you find out that you're going to have difficulty connecting, and that can really turn a project on its head. So first thing I always recommend, get that CIA in progress, and then certainly probably the next step, if you haven't done so already, talk to some solar contractors and pick one that you like and engage it. And maybe Scott, I'll pass that over to you. What are the first discussions that you're usually having with customers when they reach out to you?
Um, I think part of the consideration for the customer, what are your procurement preferences and constraints? So, do I need to go out for 3 or 5 quotes for every component of this? Can I bundle it? Can I bundle the design, construction, those sorts of things? Um, and and even before I guess we're engaging with that customer, and we do it ourselves as an owner of projects is asking that same question. Do I want to go out directly to the constructors and field quotes and just have them submit a bundled design build package, or should we work with an owner's engineer that can then work with the constructor and hold them accountable through the process? And I'll say that certainly in recent history, the latter approach has worked well for us as an owner. Um, and the other consideration is for your procurement process, thinking about the full project life cycle. So when you're going to market, don't just be asking for the design build scope, but what is the performance of that asset going to look like? And as part of that contracting process, making sure you're putting some performance guarantees in there, and that you're thinking about what is the entire project scope. So who's going to be responsible for permits? In terms of my schedule and timeline, am I leaving enough time to really get good questions, review their results, and also how am I setting objective metrics for the evaluation to compare these bidders to make sure that you're comparing apples to apples. And again, that's where having an owner's engineer can be helpful. And it's usually worth budgeting that money because they've got those tools at hand to help you make those comparisons and evaluate bids against each other, and then work with you to figure out how am I going to hold my contractor accountable through the design, construction, and commissioning stage.
All with that end goal in mind. I think it's almost like we're thinking about what that goal is and we're working backwards, right? And then every
Right.
step along the way, we're always kind of factoring in different parts of that goal with each step. So they kind of everything's kind of blending a bit together here, which is
Yes.
just fine. But okay, I guess the next question here now is once you've decided those goals and what kind of product you want to go with is what should we be looking in order to get a quality design that addresses my individual needs rather than an off the shelf or cookie cutter product. And we'll switch back to Micah here for this one.
Absolutely. Okay, so my biggest recommendation, particularly if you're not that familiar with solar, is to gather your team together. And it's great because we actually there's four main players I'd recommend in any solar project, and three of them are here. We want your contractor, your engineer or designer. We want someone from the utility, so Andrew from Innova, and then the only person that isn't here is ESA, and they're kind of going to do the final inspection, make sure that it meets code and sign off on it. Um, Regardless of whether everything is embedded behind the contractor or if you're engaging the parties individually and you're stick handling the project, uh, I would encourage you to make sure that there is good dialogue happening between the various parties and that everyone is having the opportunity to comment on various complexities and whether or not the approach being recommended is the right approach. Now, it may go without saying, but I think it's worth mentioning that if this is a very small project you're considering, maybe it's residential, um, this isn't going to be as big of a factor because there just aren't that many things to go wrong. But once we get up into the very large, where you've got maybe some different protection systems and lots of different ways of doing things, it really can be a factor where you want to make sure that everybody is on board with the approach before you commit to and start procuring materials so that you don't get that surprise later on.
Scott, you would know something about surprises, like, or
Yeah.
you've heard about some surprises, haven't you?
Yeah, certainly. Well, and this is where I think that to mitigate some of the surprises, the uh, building into your budget some allowances for external help or third party verification of things. So I think you want, if you do have a separate designer and constructor, you want to make sure that you actually budget for them to be able to meet and have sessions for to refine the designs, both so that the constructor can help bring a bit of real world pragmatism, where sometimes engineers, and I say this as somebody that was trained as one, can default to many 100% safety factors, and at the same time, the engineer can help hold the constructor accountable for making sure that they're making decisions that really will provide you with a long-term asset, because really a solar project, you should expect it to last 35-40 years now. And uh and, and then just some of the practicalities of, our switches in places where I can actually reach them, or do I have to get on a ladder and that kind of thing. So making sure you budget the time and the financial dollars to actually pay those folks for some hours to spend some time on that. And then carrying contingencies through this process as well is important, because um, almost guaranteed you're going to miss something that's going to have to be remediated or dealt with later. And partly because, as Micah mentioned earlier, changing business codes, we've run into that before, where mid project suddenly things have changed and you've got to spend some more dollars. And
Right.
then the other thing we usually budget for is having somebody else verify the constructor's work, and that can either be your owner's engineer can help you coordinate that, or if you're not engaged with one of those, on a recent project, we engaged another contractor that was local to that project to come out and verify their work. And usually they're extremely motivated to find any mistakes so that they show well for your next project.
Great.
That was the point.
Just a quick couple questions here. I'm checking the chat here. Does ISO have any input on PV systems connected to Innova's grid? And the short answer to that is yes and no. It depends on the station that the solar is connecting to. Innova owns basically all of our transformer stations, which is the upside distribution, except for one, which is owned by Hydro One. So therefore, the connection impact assessment has to throw through them. In fact, we also have another feeder that comes out of Cambridge that's also connected to another Hydro One transformer station. So there is some coordination that has to be involved there. I guess that doesn't necessarily pertain to the ISO. And I'd have to investigate if the ISO is actually involved in this. But for the most part, ANOVA is responsible for our own grid, and we can manage those systems accordingly. Thanks for the question. Okay, so let's move on to our next question. So now that we're ready to build, what are the key success factors during construction? How do I avoid costly mistakes that could delay or prevent my system from connecting? Who wants to take this one first?
I'll jump in. So I see it as you want to run your regulatory processes in parallel with your construction processes. And the two big regulatory, one is the ANOVA or the utility, and the other one is ESA. So you want to make sure that your CIA is being executed, your CCA, which is your connection cost agreement. Then you get your DC. I'm hitting you with acronyms. DCA is distribution connection agreement. Essentially, there's this process that the utility is going to be working through, and it doesn't happen overnight, but it shouldn't take longer than your construction cycle, as long as your engineer is kind of bumping that forward and paying attention to it. The last thing you want is to get to the end of the project. Your constructor has built you a beautiful solar facility, and then you find out we're still 3 months away from meeting all of ANOVA's requirements, and now it's going to sit there and languish and maybe miss the best part of the summer. So pursue that in parallel. That's the big one. And then the other thing that I personally like to do, particularly for our larger projects, and this touches on something that Scott just mentioned, I like to send a tradesperson, an electrician, out to site, maybe midway through construction, and then again at the end, to make sure that we are meeting our workmanship goals, that the thing that you bought has actually been installed well, and that you aren't going to have surprises down the road, wires that weren't connected properly, or you get, maybe some arcing or something like that, and then your system goes offline. I like to do it in the middle so that we can catch things that maybe need to be corrected while all the tradespeople are mobilized, and then we do it again at the end to make sure that that nothing has been overlooked. Those, from my perspective, I'd say those are the big ones. Scott, from your experience, you might be able to add in a few others.
Yeah, well, I think adding on to the regulatory piece of that, I totally agree. You've got to be proactive with it, chasing it all the time, and that's where I think building some of those responsibilities into the scope of making this your constructor or your owner's engineer accountable for that, keeps everybody's interests aligned. And I would say, in terms of setting internal expectations with the organization, be very conservative from the beginning. Assume that you're going to have to do, if the utility gives you a range, this may take 6 months to 9 months. Assume the 9 months. It can always improve. But on a larger project, some of it is, to the earlier question posed by one of the participants, it's sometimes not just ANOVA that's got to weigh in. They've got to consult with the transmission company, and that just blows up your timelines even further. We've done projects where it's a renewal, and you're thinking, well, we've already got all our connection agreements with the utility, shouldn't be an issue. And in fact, they make you go through the entire process again. So just in terms of managing internal expectations, assume the worst, plan for the worst, and then you can always shorten those timelines and look like a hero when you deliver it more quickly. From an owner's risk perspective, it's really important to consider the site safety as well. And so if I'm outsourcing this project build, it's a good opportunity to outsource a lot of the health and safety accountabilities, but you need to be mindful of what's happening on your site. Ideally, you've just got this project being constructed, and you can have the installer identified as the constructor, which has a specific definition under the Occupational Health and Safety Act, and a bunch of accountabilities and liabilities that come with that. But if you're in a situation where you've got other projects on the go or installations happening within an operational area, that can blur lines, and a lot of that constructor liability can then fall back on the owner. So those are things to be conscious of and really engage with the people. It's good to engage with the people in your organization that have expertise in that area to make sure that you're not only ensuring the safety of your own teams and the installers, but also that you're truly outsourcing the risk as you think you are and aren't actually carrying risks you weren't aware of.
Right. And just again, once you start scratching the surface, I know, but we have like a Form A or a pre-assessment form that can be completed and put you in touch with our engineers to help you determine all the hoops that might have to jump through, and all those, basically lay the groundwork for what's all going to be required throughout the whole project life cycle. So engagement with the utility right at the beginning is probably your first point. And more, at Nova, we have key accounts here. We're your single point of contact. So, feel free to reach out to us and ask, okay, what do I need to do here? And we're happy to help you point you in the right direction, and even point you towards Scott and Mike if you're really starting from scratch there. Great. Okay, so then we've got the project. It's on the roof. It's connected. So once it's connected and generating, how do I make sure to get an optimal return on my investment? I mean, that's why we're doing this, right? We want to make sure that money is flowing in there when we get it connected. So what are the key factors in achieving its intended performance and ensuring the longevity of this investment?
This is where I'm going to be difficult and say if you're only thinking about it now, it's too late. So really going back to your initial procurement stages, as I think we sort of hinted at, you need to be thinking about what am I trying to achieve? What are the performance objectives? And then how do I try and ensure that my project actually meets the business case? Now, if this is a case where you're going for a third-party power purchase agreement and somebody else is going to build and fund it and you're just paying for the energy delivered, maybe not as much of a concern. But if you're going to own this or a piece of this project yourself, obviously you want the business case to actually deliver, compared to what was sold to the organization's leadership. And so in a previous life, when I was building utility scale projects, it was very much the norm for the contractors to provide not only guaranteed uptime, but a guaranteed annual generation. It was yield measurements. That's not quite as common in the commercial sector, but it's something that we've successfully implemented and working with. We've done a project with Micah where he worked with us to set some reasonable performance guarantees and establishing clear ways to measure that performance. Because one of the challenges of solar, and when you're getting these projections from your vendor or the designer, is that the solar intensity is not the same every year. And so typically when you get a design target of this is going to produce 100,000 kilowatt hours per year, that is using a model that assumes that half the time over maybe a 10-year or longer period, it will be below that, and half the time it will be above that. And so when it comes to actually measuring that performance, you need the help of somebody that knows what they're doing to say, okay, based on this year of data now, did it produce, based on the solar intensity, what it should have? And we've found that not everybody in the space is willing to offer guarantees, and certainly don't expect that if they tell you it's going to produce 100,000 kilowatt hours a year, that they're going to offer that as a guarantee. The installer is going to give you something less than that. What you need to assess is that guaranteed amount enough for me to still make my business case? And then we've built in to our contracts that there's a holdback. And so 6 months or 12 months after the project's been operating, we then do this assessment to see, based on the solar resource, did it deliver what it should have according to that guarantee? And then you release the funds. So there's a strong incentive for your construction partner to work with you to make sure that you're going to get what you want, because they've got some skin in the game. Beyond building in performance guarantees into your contract, um, should really be conscious that that this takes some ongoing effort, and it's not something you just want to do off the side of your facility person's desk or your energy or sustainability person's desk. It requires some diligence, some monitoring, and it's good to establish some KPIs within the organization that you're tracking and thinking about who's going to help us through the operational phase. Are we going to handle it internally? If so, are we allocating the right time? Or do we have the right skill sets? Are we giving people the right training? Um, because you can't just assume it gets plugged on and it's producing. There are stories in the community of projects, not producing for 6 months at a time, and the owner not even being aware of it. And so it's good to make sure that you've got a plan for some who's checking the data, making sure it's producing, and that you've got a plan for regular maintenance, and that you're budgeting accordingly for that.
Thanks, Scott. Just maybe to build on what you were saying about performance guarantees, I think that they can be really valuable. And then they act a little bit like insurance. So maybe just to point out one thing for everyone to be aware of, if you make your performance guarantee requirements too stringent, the contractors are just going to bake that into their price, and you're going to end up paying more. And so where I think, Scott mentioned that project that we worked on together, we went back and forth quite a bit to try to find that happy medium. And I think we did a great job of that, so that there was protection for the customer without putting the contractor, the people bidding on it, in a place where they just felt like they had to just add that 20% to their quote and be done with it. And there can be a real art to that. So just be aware of that if you're thinking about that this is a nuanced topic, and maybe get some help. Reach out to Scott. He thinks about this stuff a lot. He really can help you with that a lot. And then the other thing I want to mention on your uptime is the value of paying attention. We can come up with systems and AI and computers and their services, third-party monitoring, all of this other stuff. In my experience, it all boils down to have you put things in place so that you are able to pay attention to the solar facility and see whether or not inverters have gone down or inverters are underproducing, and not just like the first week that the system starts up, but in the first month, in the first year, in the 10th year. Do you have something in place so that you will notice that right away? And you hear Scott talking about inverters that have been down for 6 months and nobody notices, and you think that would never happen to me. But the number of organizations that have solar facilities that are underperforming by 10, 20, 50%, and it's simply because there's nobody within that organization that is paying attention to when an inverter goes down for any reason at all, whether it's it's an error code, or a fuse has blown, or something, maybe an animal got in there and started chewing on something. But if you can identify that and address it right away, you can keep your uptime where it's expected to be, rather than losing all of those kilowatt hours simply from downtime because nobody was paying attention.
Right.
Yeah,
So
you don't necessarily need to do a full wrap on the O&M, where you pay sometimes usurious rates where they'll give you an annual quote to cover all of the incidentals and repair and maintenance costs. You don't necessarily need to go that way, but would recommend at least an annual site visit with some thermal imaging, spot bad panels, and check the inverters and that kind of thing as well. So you want to be constantly watching it, but also at least budget annually to get it looked at, because some of these things are not just straight on or off. Some things degrade with time, and if you're paying attention, you can catch it, rather than just suddenly have the whole system go down, which is really costly.
and so on that, and I'm being specific here, Scott, when in terms of say if something fails right away, right after out of the gate, right, you're off and running, and then you might get a lemon out of the factory, and now you're trying to scramble in terms of dealing with the warranty and dealing with the contractor and whatnot. So I guess how would you, or what's the best way to handle with that situation?
One thing that we've employed that seems to work all right is having your constructor bid on the first couple of years of maintenance as well, or at least during that period where you've got uh, the period of their construction warranty, and I'd say at least a year because you really want to get through the teething problems because things do happen. We've got a project that we completed in Q2 of this year that I think we're on the third inverter from a reputable company. And these things happen. So you do want to make sure that you're keeping your construction partner or installation partner at the table and anticipate that you will have some challenges in that first year, at least teething. Things do tend to settle down after the first year or two, but carry some budget and design your agreements to make sure that you're keeping them engaged with you. And that's the other benefit of this performance guarantee notion as well for the first year that they're financially on the hook if this thing is out of production for quite some time.
Yeah, money is a good motivator, that's for
Yeah.
sure. Okay,
Maybe just
great.
to add to that,
Yeah.
it is really not uncommon for failures to happen in the first year. Don't panic. Um, Inverters failing, modules failing, it happens. It's not unusual. The good news is that you get through those initial failures or warranty replacements if they happen, and then usually the system will run just like a champ for the next 10, 20 years. In most circumstances with solar, if something's going to fail, it fails right away.
And I will add, don't I would encourage you not to cheap out. I mean, prices are really competitive, but there was sort of in the industry what's known as tier one components, both for panels and inverters. And recommend you always go that way because then they're all competitive with each other in terms of the length of the warranties and their ability to support those warranties. Don't be surprised as you're getting into some newer technologies that sometimes people exit the business or they're absorbed by others. It's not as big a problem as it was 10 or 15 years ago, where companies were constantly eating each other or disappearing. But go with a reputable parts with where an OEM warranty is going to carry you on, and also where that OEM might be around in some cases on a 25-year solar panel warranty when your contractor is no longer around. So it's worth investing the little bit extra in reputable quality components.
That's good. Yeah.
Yeah.
I mean that's the case with a lot of electronics it seems these days, although you can still buy a reputable one and still get the lemon out of the factory, unfortunately. So, but
Yeah, but at least they'll have parts ready to ship the next day.
yeah. Okay, all right. We'll move on here. We're getting close to time, so just being cognizant of that. We've already kind of had lots of discussion about this, but as seasoned professionals in the industry, you've seen the perils and pitfalls of many installations. What are the most common missteps you see businesses make, and what's your top piece of advice for them? So maybe just give me one piece of advice that you want to leave our viewers with today.
Hire a reputable contractor.
There we
You
go.
get a good contractor, your project's going to go well, no matter what. You get a lousy contractor, everything's going to go poorly. Hire somebody good.
And I'll add to that, trust but verify. So hire somebody reputable, but then hire somebody else reputable to check their work. Um, we,
Absolutely.
in terms of lessons learned, we've had some situations where we've worked with good contractors that we'd still work with again, but people make mistakes when it comes to design and the software used for modeling it's a bit of an art, and you've got to enter certain data, and sometimes people can leave stuff out. So I think you want to create an environment where you've always got somebody double checking the work and validating that. And again, that's why I'll come back to why this notion of having an owner's engineer that's supporting you and double checking the work of the contractor is really valuable, because even the people with best intentions can make mistakes.
And I'll just echo Michael there with having a good contractor. I know I helped Jerry with a project, and and it was just smooth sailing when you had the right contractor on board. It just made life very easy, and it just yeah, totally echoed that.
Yeah, and I wouldn't necessarily just rely on like how many projects has somebody done. I think it's taking the time to meet with these folks and understanding what their philosophy and their plan is, and do they give you confidence from the beginning, not only about their methodology of the pricing, which most organizations are making decisions based on who's most competitive price wise, but do you have confidence in what they're telling you about the schedule and their ability to work with the regulators and that sort of thing. It's uh, if your gut just tells you it doesn't feel right, then work with somebody you're comfortable with, because that's it's worth something to be able to sleep at night having confidence in your partner.
Great. Okay. So yeah, so what do we want to leave our viewers with today? This is the kind of things that I took away from the conversation is that proper planning and early collaboration between the client, engineer, developer, and utility set the foundation for a smooth project. And solar systems are low maintenance, but not no maintenance. You're not setting and forgetting it here. So regularly monitoring it and upkeep will protect your investment, making sure that money generating system is going to keep on doing what it's intended to do. So with that, I think that concludes our great chat. If there's any questions from people online here, feel free to put them in the chat, raise your hand, unmute yourself. Any specific questions for our guest here today?
And maybe just to add to that, while you're thinking about your questions, if there is anything that we said that maybe you'd like us to review a little bit slower or talk more about, hard for us to know what's landing and what's not, but we would love to hear back from you as you've listened to us. What are you understanding? What do you want to know more about?
Everybody's still processing, so that's okay. Lots, lots of thoughts there. There's no problem there.
So until that first question rolls in, oh, there it is. Thank you.
Yeah. Okay, yeah. So for a typical rooftop system, what would you recommend be the annual budget for OEM? I mean, you O and M. I mean, you mean there, right? O and M or OEM? O and M. Yeah, O and M.
Operations and maintenance.
Yeah. Thanks.
It I'll say it really does depend on the size and how long how many panels you have, how long for uh, the contractor to go over the site and do all the imaging. But I would say, it's normally a few grand a year on a typical site. And then there are third-party services you can get as well, where they'll monitor your system and send you reports weekly or bi-weekly on how it's generating. Those can be good solutions as well if you don't have the in-house expertise. Like we we use redundant methods, so we've got an external party watching them for us, but we've also got an engineer that looks at the data on all our sites and sees how they're performing. And it just, again, trust but verify. It allows you, if somebody misses something, then sometimes that other party can catch things. And then just be conscious that in the early years, you're not going to have to spend as much on maintenance. And then once you get past probably year 10, you got to be conscious that your inverter is going to fail at some point, and so you want to be carrying budget to replace that. Sometimes they'll get to 15 years, but you'll want to make sure you've got money for that. And things happen with time. Some panels go bad. Sometimes wiring comes loose, or the squirrels get at it or whatever. And so what we typically pair that along with that annual inspection, we have a sort of an existing agreement with a contractor for a site. So we already have their rate sheet, and they're guaranteeing that rate sheet in a certain call out time. So we know that we're you don't have to pay a retainer. Normally, you just sign an agreement with these folks and have them do the annual review. But that way that they're prepared to be out to site the next day and look at it, and then you you've got a good sense of what their rates are going to be, so you're not surprised. So a newer project, less than $5,000 a year. As it's aging, depending on the size, you might want to carry a bit more than that.
Thanks, Scott. Another question here from Deepak, and I think we'll maybe chat about this offline. I know we've had discussions about it already, about the VPPA, the Virtual Purchase Power Agreement, and if you can use solar to offset GA costs. And I think it's a bit of a niche situation there where there's a bit of specifics that come into play there. So we'll take that one offline there, Deepak, unless Scott or Micah, you have any specific insight to share with that one?
Very briefly, my understanding is that the virtual element of it is only available to market participants at this time. So we're talking about maybe 100 entities in Ontario that are eligible to participate. Everybody in the solar industry is hoping that the government opens that up and we have more virtual net metering, but we continue to hope. GA cost reduction, I wanted to mention, we actually have a project in Eastern Ontario that is using a solar facility without batteries to reduce their GA by offsetting demand during those 5 peak hours. And it's been running for about 6 years now, and it's working. So some people think that you can't use solar to offset GA. You can. It works.
Yeah.
But I would manage your expectations around that, certainly, as Mike is saying. Not only do you have to become a market participant, which you can do, you can register. I think you've got to be over a megawatt. But then there's an additional level of sophistication effort. You got to pay the fees, remain registered, be able to have the sophistication to transact in the market, and then you've got to find a counterparty that's willing to offer at a competitive rate to do the GA reduction. Usually, it's easier to get the benefit of the GA reduction along with consuming the energy by having that on site without a really comprehensive virtual net metering policy in the province. I'm not aware of any meaningful virtual PPA agreements for solar for GA reduction that have come together yet, because it's just been hard to make the economics work even for some big projects.
It's so niche.
Yeah.
Yeah.
Okay, we got time for one more question here from Julia. So how does solar help with GA and ICI events occur when ICI events occur at nighttime without battery? And yeah, and for the most part, they're happening around the 5 o'clock hour, and solar is still producing, but it's kind of waning by that time. So that's my 2 cents there. If you guys have anything to add?
Yeah, not great when there's no sun.
Yeah.
And the other thing to be aware of is that with the electrification of the grid and more electrification of heating, there's increased likelihood of some more winter peaks, not just summer peaks in the future. And so then it's less impactful. It's really under the current regime where there's a lot of cooling, and it's hitting at that 5 p.m. where you get some benefit. And I don't know, Micah, what do you typically like? I think we see a solar project that's designed to net meter on a building can contribute sometimes 20-25% of the GA, something like that, typically when those GA events are happening.
With that, yeah, typically we're watching for GA events that are around 4, 5, 6 p.m. They're often in the June, July, August heat waves. We would have set up that solar facility so that it's 45 degrees facing west, so that we're catching more of the afternoon sun than morning or midday. And we've had solar facilities that are kind of catching between 40 and 70%. So they're actually generating pretty well. And the reason for that is basically if you've got a heat wave that is driving that GA event, then probably there's going to be overlap between sunshine and the GA event. And then after that, it essentially becomes a question of statistical analysis. What is the probability that I'm going to catch my GA events with meaningful solar production on X number of years out of the total life of the solar project? And you do that statistical analysis. And then if you're happy with the worst case scenario, then you should do the project. And if you're not happy with the worst case scenario, then it's probably not for you.
Thank you.
Thank you. And with that, we are at time. It's been a great talk today, guys. I really appreciate you being here. I think there's been, again, a lot to consider, a lot to think about for people that are thinking, oh, hey, let's get solar. You know, it's a bit more involved with that. So I hope that everyone's taking away some good practices here and understanding, you know, at least where to start the conversation and what needs to be done there. So. Again, thanks to Scott and Micah for our guests today and everyone else joining us on the call. Feel free to reach out if you have any other additional questions after this. A recording will be on our website with the slide deck, and we'll send a follow-up email as well. So the conversation keep on going after this session, and we look forward to hearing from all of you. Thanks again,
Andrew, thanks so
everybody.
much for setting
Thanks
this
very
up.
much.
This has been great.
Excellent.
Thanks, been a pleasure.
Thanks.